Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Certificate Programs, Certificate in Information Technology, CIT, CIT 001 Fundamentals of Computer Systems, Block-2 Problem Solving Techniques, Unit-1 Algorithm and Flowchart, 1.0 Introduction. Intelligence is one of the key characteristics which differentiate a human being from other living creatures on the earth. Basic intelligence covers day-to-day problem solving and making strategies to handle different situations which keep arising in day-to-day life. 1. Person goes bank to withdraw money. After knowing the balance in his account, he/she decides to withdraw the entire amount from his account, but he/she has to leave minimum balance in his account. Here deciding about how much amount he/she may withdraw from the account is one of the example of the basic intelligence. During the process of solving any problem, one tries to find the necessary steps to be taken in a sequence. In this unit you will develop your understanding about problem solving and approaches. 1.1 Objectives. After going through this unit you should be times able to define problem, times able to define algorithm, times write algorithms for simple problems, times explain properties of an algorithm, times the meaning of flowchart, times explain the need of flowchart, times explain different symbols used in flowchart, times draw flowchart for simple problems, and times convert a flowchart into an algorithm and vice versa. 1.2 Problem solving. Can you think of a day in your life which goes without problem solving? Answer to this question is of course, no. In our life we are bound to solve problems. In our day-to-day activities such as purchasing something from a general store and making payments, depositing fee in school, or withdrawing money from bank account. All these activities involve some kind of problem solving. It can be said that whatever activity a human being or machine do for achieving a specified objective comes under problem solving. To make it more clear, let us see some other examples. Example 1. If you are watching a news channel on your TV and you want to change it to a sports channel, you need to do something. Move to that channel by pressing that channel number on your remote. This is a kind of problem solving. Example 2. One Monday morning, a student is ready to go to school but yet he/she has not picked up those books and copies which are required as per timetable. So here, picking up books and copies as per timetable is a kind of problem solving. Example 3. If someone asks to you, what is time now? So seeing time in your watch and telling him is also a kind of problem solving. Example 4. Some students in a class plan to go on picnic and decide to share the expenses among them. So calculating total expenses and the amount an individual have to give for picnic is also a kind of problem solving. Now, broadly we can say that problem is a kind of barrier to achieve something and problem solving is a process to get that barrier removed by performing some sequence of activities. Here it is necessary to mention that all the problems in the world cannot be solved. There are some problems which have no solution and these problems are called open problems. If you can solve a given problem then you can also write an algorithm for it. In next section we will learn what is an algorithm. 1.3 Algorithm. Algorithm can be defined as a sequence of activities to be processed for getting desired output from a given input. Webopedia defines an algorithm as a formula or set of steps for solving a particular problem. To be an algorithm, a set of rules must be unambiguous and have a clear stopping point. There may be more than one way to solve a problem, so there may be more than one algorithm for a problem. Now, if we take definition of algorithm as a sequence of activities to be processed for getting desired output from a given input, then we can say that 1. Getting specified output is essential after algorithm is executed. 2. One will get output only if algorithm stops after finite time. 3 activities in an algorithm to be clearly defined, in other words, for it to be unambiguous. Before writing an algorithm for a problem, one should find out what are the inputs to the algorithm and what is our expected output after running the algorithm. Now let us take some exercises to develop an algorithm for some simple problems. While writing algorithms, we will use following symbol for different operations: for addition, for subtraction, for multiplication, for division, and for assignment. For example, AX3 means A will have a value of x3. 1.3.1 Example of algorithm. Problem 1. Find the area of a circle of radius r. Inputs to the algorithm: radius r of the circle, expected output, area of the circle. Algorithm, SWIT P1, read input the radius r of the circle. SWIT P2, area pi r, calculation of area. SWIT P3, print area. Problem 2. Ravi has to attend at least 70% of practical classes for C programming to be eligible to appear in the examination. There are total 50 practical classes for C programming. He has attended 20 out of 30 classes held so far. Find at least how many more classes to be attended by Ravi to be eligible for appearing in practical examination. Inputs to the algorithm: I. Percentage of attendance required. 2. Total number of classes. 3. Number of classes held so far. 4. Number of classes attended so far by Ravi. Expected output: number of classes to be attended to become eligible for appearing in examination. Algorithm, SWIT P1, read total number of classes C. SWIT P2, read percentage required P. SWIT P3, read classes already attended CA. SWIT P4, total classes to be attended CT CP 100. SWIT P5, more classes to be attended CM CA. SWIT P6, print CM. Problem 3. Convert temperature Fahrenheit to Celsius. Inputs to the algorithm: temperature in Fahrenheit, expected output, temperature in Celsius. Algorithm, Step 1. Read temperature in Fahrenheit F. Step 2. C5 nines, F32. Step 3. Print temperature in Celsius. C. Problem 4. Ram Shiva goes to market for buying some fruits and vegetables. He is having a currency of 500 rupees with him for marketing. From a shop he purchases 2.0 kilograms, apple priced rupees 50.0 per kg, 1.5 kilograms mango priced 35 rupees per kg, 2.5 kilograms potato priced 10 rupees per kg, and 1.0 kilograms tomato priced 15 rupees per kg. He gives the currency of 500 rupees to the shopkeeper. Find out the amount shopkeeper will return to Ram Shiva. And also, tell the total item purchased. Before we write algorithm for solving above problem, let we find out what are the inputs to the algorithm and what is expected output. Inputs to the algorithm are: 1. Amount of different items purchased, for example 2.0 kilograms apple etc. 2. Price of the items, for example mango is 35 rupees per kg. 3. Total amount given to the shopkeeper. Expected output: amount to be returned by shopkeeper after deducting total price of the purchased vegetables and fruits, and total items purchased. Algorithm, Spec 2, read amount purchased and unit price of Itemi. SWIT P3, total amount of Itemi price per unit of Itemi. SWIT P4, II1, SWIT P5, repeat step 2 to 4 for each purchased item. SWIT P6, read total amount given to the shopkeeper as given amount. SWIT P7, refund amount given amount total. SWIT P8, print amount to be refunded as ours. Refund amount. SWIT P9, print total item purchased are I. Problem 5, find factorial of n. Inputs to the algorithm are: 1. Number n. Expected output, factorial of n. Algorithm, Step 1, result R1. Step 2, I1. Step 3, read the number n. Step 4, compare I with n. Step 5, if I is equal to n, then R asterisk I, otherwise go to step 8. Step 6, I plus 1. Step 7, Repeat step 4 and 6. Step 8. Print R. Problem 6. Print the table of n. Inputs to the algorithm are number n. Expected output. Table of n. Algorithm. Step 1. I arrow 1. Step 2. Read n. Step 3. If I happy smiley 10 then print I asterisk n, otherwise go to step 6. Step 4. I plus 1. Step 5. Repeat step 3 and 4. Step 6. Stop. 1.3.2 Properties of algorithm. Donald Irwin Nath has given a list of 5 properties for an algorithm. These properties are 1. Finiteness. An algorithm must always terminate after a finite number of steps. It means after every step one reach closer to solution of the problem and after a finite number of steps algorithm reaches to an endpoint. 2. Definiteness. Each step of an algorithm must be precisely defined. It is done by well-thought actions to be performed at each step of the algorithm. Also, the actions are defined unambiguously for each activity in the algorithm. 3. Input. Any operation you perform needs some beginning value quantities associated with different activities in the operation. So the value quantities are given to the algorithm before it begins. 4. Output. One always expects output result, expected value quantities, in terms of output from an algorithm. The result may be obtained at different stages of the algorithm. If some result is from the intermediate stage of the operation, then it is known as intermediate result, and result obtained at the end of algorithm is known as end result. The output is expected value quantities always have a specified relation to the inputs. 5. Effectiveness. Algorithms to be developed written using basic operations. Actually, operations should be basic, so that even they can in principle be done exactly and in a finite amount of time by a person, by using paper and pencil only. Any algorithm should have all these 5 properties, otherwise it will not fulfill the basic objective of solving a problem in finite time. As you have seen in previous examples, every step of an algorithm puts you closer to the solution. While writing an algorithm for a problem, if you are writing some operations such as a loop for performing some operations repeatedly, then your loop must stop after finite number of iteration / repetition. While solving complex activity, for example for getting the total sum of all the items purchased from a general store, the better approach is to calculate the price of all the items separately and then add them to get the final sum. By doing this, you assure the finiteness and effectiveness of the operations in your algorithm. 1.4 Flowchart. The flowchart is a diagram which visually presents the flow of data through processing systems. This means by seeing a flowchart one can know the operations performed and the sequence of these operations in a system. Algorithms are nothing but sequence of steps for solving problems. So a flowchart can be used for representing an algorithm. A flowchart will describe the operations and in what sequence are required to solve a given problem. You can see a flowchart as a blueprint of a design you have made for solving a problem. For example, suppose you are going for a picnic with your friends, then you plan for the activities you will do there. If you have a plan of activities, then you know clearly when you will do what activity. Similarly, when you have a problem to solve using computer, or in other words, you need to write a computer program for a problem, then it will be good to draw a flowchart prior to writing a computer program. Flowchart is drawn according to defined rules. 1.4.1 Flowchart symbols. For drawing flowchart, standard symbols are used. These symbols are given in Table 1. Table 1. Flowchart symbols. 1.4.2 Meaning of flowchart. A flowchart is a diagrammatic representation of algorithm. It clearly illustrates the sequence of operations to be performed for getting the solution of a problem. For simple problems, flowcharts may not be very useful, but for complex and large problems, flow charts are very helpful in understanding the logic of the problem. Flowcharts are used as a link of communication between programmers and clients for whom the program to be developed. If you are having a flowchart for your program, then you can use it in explaining the program to others. Once the flowchart is drawn, it becomes easy to write the computer program. Flowcharts can be used for preparing a better documentation of a complex problem. 1.4.3 Guidelines for drawing a flowchart. Flowcharts are drawn using slanted flowchart symbols. While drawing flowchart, some guideline to be followed. Below are some guidelines for drawing flowchart. 1. First of all, list all necessary requirements in a logical order. 2. The flowchart should be clear and easy to understand. There should not be any ambiguity in understanding the flowchart. For doing this, it is necessary to have all the steps and operation very simple. 3. Usually direction of the flow of data procedure in the system should be from left to right or top to bottom. 4. Only one flow line should come out from a process symbol. 5. In the case of use of decision symbol, only one flow line should enter to it, decision symbol, but there may be 2 or 3 flow lines coming out of the decision symbol, one for each possible answer. 6. In a flowchart, only one flow line should come to the end symbol. 7. While writing steps inside the processing symbol, steps should be brief and if necessary, you can use the annotation symbol to describe data or processing one steps more clearly. 8. In the case of complex flowchart, connector symbols to be used for reducing the number of flow lines in the flowchart. 9. Intersection of flow lines should be avoided to make a flowchart more effective and for better way of communication. 10. A flowchart must have a logical start and end. 11. Once a flowchart is drawn, its validity should be tested by passing through it with a simple set of test data. 1.4.4 Some examples of flowcharts. Now, we will discuss some examples on flowcharting. These examples will help in proper understanding of flowcharting technique. This will help you in program development process in next unit of this block. Figure 1. Flowchart for factorial in 1.4.5 Advantages of using flowcharts. As we discussed, flowchart is used for representing algorithm in pictorial form. This pictorial representation of a solution system is having many advantages. These advantages are as follows. 1. Communication. A flowchart can be used as a better way of communication of the logic of a system and steps involved in the solution to all concerned, particularly to the client of system. 2. Effective analysis. A flowchart of a problem can be used for effective analysis of the problem. 3. Documentation of program system. Program flowcharts are a vital part of a good program documentation. Program document is used for various purposes like knowing the components in the program, complexity of the program, etc. 4. Efficient program maintenance. Once a program is developed and becomes operational, it needs time-to-time maintenance. With help of flowchart, maintenance become easier. 5. Coding of the program. Any design of solution of a problem is finally converted into computer program. Writing code referring the flowchart of the solution become easy. 1.4.6 Limitations of using flowcharts. 1. Complexity of logic. If program logic is complex, then flowchart of the program becomes complicated. 2. Alterations and modifications in logic. Any alterations in the program logic may require redrawing of flowchart completely. 3. Reuse is not possible, as the flowchart symbols cannot be typed, always. Reproduction of flowchart symbols are required. 1.5 Summary. In this unit you have learned about an algorithm. How an algorithm to be written. This unit explains the properties of an algorithm such as finiteness, definiteness, and effectiveness. Further, this unit covers about the flowcharting. Flowcharting is a way of representing algorithm in the form of a diagram. You have learned about different symbols used in drawing flowcharts. This unit also explains about guidelines for drawing flowcharts. Finally, in this unit we have discussed about advantages of flowcharts and limitations of flowcharts. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.